What is up everyone, welcome back to a brand new video. In today's video, we are going to be building an electric skateboard that goes 35 miles an hour, has a range of over 15 miles, can climb pretty steep hills, and is less than $1,000. So without further ado, let's get into the video. The first thing that we're going to get to is the drivetrain, which is how the motors are connected to the wheels. Here are all of the parts that we used in our drivetrain, all laid out so you can get an idea of the things that you'll need. The first thing that we have are these trucks, which are caliber 2 truck clones. We got these from DIY electric skateboards or torque boards. It's crucial that you use either caliber 2 trucks or caliber truck clones because of the D shape that they have on their hanger, enabling them to fit with your specific motor mount, which we have here is the Boardnamics idler tensioner caliber 2 truck motor mount. The next part that we have are these 50-55 200 kV motors from Flipsky. These are different than any other motor that we've used before because they're 50mm instead of 63mm, and they also have a D-shaped shaft, enabling them to have specific motor pulleys that don't need a keyway and making it a lot easier to assemble while also being more reliable. So the first thing that you're going to want to do is place your motor mount on your motor and then use the 4 M4 bolts to secure the motor plate onto your motor. After all 4 bolts are in, the motor will sit nice and flush with the edge of the motor plate, and you'll want to do the same thing on the other side for your other motor. Next we have the motor pulley, which is included with your motor. You'll want to take the set screw included and screw it into the side of your motor pulley. Next you can place the motor pulley onto the shaft of the motor, and it's pretty easy because there's only one way you can do it with the D-shaped shaft. To prevent the pulley from sliding off, you can tighten the grub screw on the edge of the pulley all the way down using an Allen key. I personally really loved this D-shaped motor shaft system, as the motor pulley sits nicely, it doesn't need a keyway, and it's easily fastened to the motor. Again, you'll want to make sure that you do this to both of your motors. The next step is to take the clamping portion of your motor mount and get that assembled. So you'll take the cap head screws included and then put them through the 2 clamp pieces and then the nut on the other side so that it kind of creates this clamping vise system that'll prevent the 2 pieces from moving outwards. You can then slide this piece over your hanger of your truck in the correct orientation, which you'll see that the 2 D-shaped pieces of the hanger and the mount itself will line up. You can do this on both sides since you'll have 2 motor mounts. At this point, we're just trying to get our alignment of these mounts correct so that we have enough room for the pulleys. So what we did was to take our wheel, make sure that the wheel pulley kind of fit on, and then place the motor mount in a place that we thought would allow for enough clearance for the motors to both fit on, but also for the wheel pulleys to not scrape against the plate. Which, by the way, we're using these 100mm MBS all-terrain wheels with 36 tooth bolt-on wheel pulleys from torque boards, which we won't show you how to assemble because we've shown this in many other videos. To further confirm that you've got your mount in the right position, you can slide the plate on top of it. It's not going to matter what angle that you put this plate on because you're going to mount it to the deck and then you can figure out what it needs to be at, but this loose fitting will allow you to see if you've got the mount in the right position, and once it's there you can disassemble everything that you've just put together and then actually tighten down the motor clamp on the mount. To secure the clamp to the hanger of the truck, you'll want to use an Allen key that's the proper size for the bolt and a wrench that's the right size for the nut, and then you'll want to make sure that you do both sides evenly to ensure that the clamp is nice and flushly on and not too far to one side. This is a really awkward and difficult thing to do since it can be a bit finicky. And once again, you're going to want to do this to both of your motor mounts. Once the clamps are securely on, you can finally place the motor mount onto the clamping portion. This is an adjustable plate so that you can adjust the angle, and you'll attach it using these M4 bolts. Simply slide the 4 bolts through both the plate and the clamp portion, and then you can adjust the angle slightly to what you want, but it won't matter too much because you'll adjust it later. You can then place the 4 nuts on the opposite side of those M4 bolts until you clamp them together, forcing the plate to stick to the mounting part. And then once again, you'll need an Allen key and a wrench to secure it all the way down. Tighten the plates almost all the way just so that they stick to the mount nicely, but not so far that they won't move anymore because you'll adjust their final position once the trucks are mounted to the deck and you'll know what kind of clearance you need. It is a really tight fit on this rear truck, but it is possible to make it work. Now, stepping away from the mechanical aspect of this build, we're going to move into what deck we're using, which is this 39-inch drop-through deck that we got from Skateshred.com. Skateshred offers a variety of really nice decks. They're pretty cheap, which is a really nice thing, but they're also really good to make electric skateboard builds out of, since there's so much flexibility in which one you can get. To attach the truck to the deck, the first thing that we had to do was undo the single kingpin bolt and then take off the hanger from the base plate, because you'll need to mount the base plate first through the top of the deck, and then you can reattach the hanger of the truck. This is because it's a drop-through deck. On any other kind of deck, you wouldn't have to do this. Once the base plate is through the deck and mounted to it, you can reattach your hanger, tightening it with a T-tool. At this point, we can adjust the final angle that we want our motor plates to be at, and thus our motors and how much clearance they'll have with the deck. You'll want to make sure that you have a little bit, and this is the amount that we chose, which is just ½ an inch or so that when you turn, your motor plate won't hit the deck. Now moving back into the drivetrain, we have our belts, which are these 315mm HTD5 belts, which we got from Pulley belt, which has a lot of different belts. And then once again, we're using these wheels, which are the 100mm MBS wheels with 36 tooth pulleys. We first slid the belt over the axle and then the motor pulley, and then added these 4 speed rings onto our axle. We did this because otherwise our pulley would hit the motor plate because they're 15 instead of 12mm. So the next thing we did was to slide the wheel over the axle and then spin the pulley until it aligned itself with the belt. You'll notice that the belt does not have the right tension and that you can't adjust the motor, and this is because you adjust your tension instead with an idler pulley, which is just an extra pulley that goes on your belt to increase or decrease your tension. So you put the idler pulley inside the little slot on the mount, and then you can tighten it using an Allen key. You can adjust your tension really easily with this, and I quite like this design. It also allows your belt to grip to more teeth, and thus allowing you to have more traction and less slippage. For the tension, you'll want to make sure that it's not too tight, otherwise you'll snap the belt, but also not too loose so that it won't grip. You'll then want to repeat this exact process for the other side so that you have a dual drive. With the drivetrain done, it's now time to move into the electronics, which are the simple part of this build. The battery we are using is a 12S2P 30Q battery, which we got from Torque Boards a little while ago. This battery is really nice because it comes with a power switch included, an indicator. It also comes with a charge port, as well as some USB ports to charge your remote or a phone on the go while riding. If you're following along and you're looking to find a 12S2P 30Q pack, I would recommend checking the one out at Boards. It's a pretty good pack and it'll perform exactly like this one. The enclosure that we're going to be using is the enclosure that comes with the 12S2P battery from Torque Boards. And unfortunately, since they don't sell this battery anymore, you can't get this enclosure to go along with it. For the sake of this build, we're going to be using it, but if you're looking for an enclosure, you can always find one on Boards since they have a wide variety of enclosures for batteries this size. Moving on, we have the ESC that we're going to be using, which is the bound motor ESC, which is essentially a dual version 6 VESC. It's not the highest quality of ESCs out there and doesn't deliver as much power as some other options, but it's at a really good price. The first thing that we did was to place the battery inside of the enclosure. We lined it up so that all of the indicator and switch and charge port would be facing the outside, that way we could access them. Next, we attached the bound motor ESC, which just plugs in with an XT90 connector. And that's pretty much it in terms of wiring any electronics, since the receiver is already built into this ESC. This is how we ended up configuring it inside of the enclosure, and it's not really symmetrical, but it makes sure that everything fits in that tight little space that's given for the ESC. The only thing left to do is just connect the phase wires, but before we did this, we made sure that the orientation of the wires coming off the mount was correct. The way that we initially did it made it so that the wires pointed upwards away from the enclosure, and it made it really awkward to fit inside, so we ended up rotating the motors 90 degrees so that the wires went down and towards the enclosure. This makes a huge difference and makes everything look a lot sleeker. The next thing that you can do is to put all of the phase wires through the holes in the edge of your enclosure. That way you can connect them once they're inside to your VESC. It's a little bit of a tight squeeze, but they'll all make it in there. You can then flip over your enclosure so you have access to the inside, and once you've done this, you can connect all of the phase wires together to those on the ESC. 3 wires will go into one side from one motor, and 3 wires will go into the other side from one motor. You'll have a 1 wire left over, which is this sensor wire, which needs an adapter that's included with the motors and with the ESC. 1 adapter is from your motor wire to the sensor wire, and 1 is from the sensor wire to the connector included on the VESC. It's kind of weird since all of the motor and the ESC use these abnormal connectors than the regular 6-pin JSTs on most VESC sensor wires. But you'll be able to connect the sensor wire port wires all together using all of the adapters. At this point, everything in the build is connected, and the only thing needed to get this thing up and running is to plug it in and connect it to your computer so that you can open up VESC Tool 1.29, which is the recommended VESC tool for the bound motor ESC since it's not very upgradable, which is kind of unfortunate, but it still works great to get these things up and running. We programmed the motors in censored FOC mode, and if you're wondering how we did this, we'll have a tutorial linked in the top right corner here, so you can watch how to program your VESC. The only thing different about the bound motor one is that you'll need to program each side individually. The only part we have left to talk about is the remote, which is the remote included with the bound motor ESC. I think that it's super nice that they have a remote that's already completely paired and included with an ESC, and all you need to do is program your VESC to get it up and running. Overall, the remote works well, and I don't have any problems with it. Now that the VESC is programmed, the only thing to do is to test to make sure everything works, which you can do by just doing a simple bench test by turning your board and remote on and throttling it to see if it works, which in our case it did. With the motors ready to run, all we had to do was to seal up the enclosure and fasten it to the deck, which we did using these threaded lock nuts. We already had them mounted to the deck, and we have 6 in them, 4 in each corner and then 2 in the midpoint of the enclosure. These are super nice because it eliminates the need for a nut and bolt system. All you need to do is just worry about one screw, which goes through the bottom of your deck with a washer through your enclosure and then nicely into those threaded lock nuts already in your deck. The final step is to just mount your front truck to your deck, which you do the same thing that you did to your rear truck. Just take off the base plate from the hanger, mount the base plate to the deck, and then place the hanger back on, and the wheels and everything were already mounted, so at this point we were done, and this is what the finished project looked like. Having been riding this board for a couple weeks now, I can say that this electric skateboard is so much fun to ride. Not only is it super easy for any beginners to just hop on and get right to it, but it also offers a bunch of higher end specs that you won't be able to find on traditional pre-built electric skateboards, primarily the top speed, which is a whopping 35 miles an hour. The torque obviously isn't as great as some other DIY builds, but it still is quite impressive. As shown here, we're climbing hills that are around 22% with relative ease, which is not too shabby at all. The total price for all of the parts in this build was right around $925, give or take. You might have a little more from shipping or if you choose different wheels or a different deck, but it's right around that $900 mark, which isn't bad at all for a board that goes 35 miles an hour, has a range of 15 miles, and can climb hills up to 25%. The one thing I will say that I would absolutely recommend changing is the wheels. We already had these 100mm MBS wheels on hands, but they do take quite a while to break into before actually feeling good. I would just recommend getting some 97mm ABEC flywheel clones, or if you have a little bit more money, buy something like the Torqueboard 110mm wheels, some BOAs, or anything that's a little bit higher quality. Of course, that's just if you have a little bit extra to spend. Another really great upgrade if you're looking to spend a little bit more is just upgrading to some 6355 motors. This is going to up your power by so much while maintaining that same top speed and just slightly decreasing range. It also might be a good idea if you're using standard caliber trucks to just go with 12mm wide pulleys and belts instead of the 15 that we used, because it does cause some issues with all of those extra speed rings. Overall though, this board was so much fun to make and even more fun to ride, so if you're looking for a mid-range price board with decent specs, this is definitely going to be a super great and fun to make DIY build for you. As usual, thank you guys so much for watching. If you enjoyed the video, please make sure to leave us a like and comment down below what you think of this DIY electric skateboard. If you're looking for some parts for a DIY electric skateboard, also go make sure to check out our online store Propulsion Boards for lots of awesome DIY electric skateboard parts. We will have the link in the description so that you guys can find that easily. On a final note, if you guys aren't already subscribed, please make sure to go down and hit that subscribe button so we can get you guys some more awesome DIY electric skateboard content. Once again, thank you guys so much for watching, and we'll see you guys in the next video.